We are Team 44 and the title of our project is Assessing Service Satisfaction Using Sentiment Analysis. Our project partners are Sally Atkinson from the NHS and Christopher Magnosia from Microsoft. Our system consists of a front end and a back end. The back end is made up of an API that we created using Python and the Flask framework. The front end makes use of the Power BI visualization tool, which we chose to use instead of a web app, as it's already in use by our client, so when we hand over our project to them, it will be easier for them to pick up and use. For a detailed explanation of the system architecture diagram, please see either our client video, our website, or our user manual, but I will now give a high-level overview of how the system works. Our Power BI file is a preset bunch of visualizations and a set of SQL commands so that when data is loaded into Power BI, a set of tables and functions are automatically created and run using the SQL we wrote, and the visualizations are populated. The way Power BI gets this data is through a small Python script. This script makes a request for the data to our API. Our API then checks to see if the data it needs has already been analyzed and is stored in the database. If the analyzed data needed is stored in the database, it is then retrieved from the database and sent back to Power BI, where the tables are then created, functions are run, and visualizations are populated. If it hasn't been analyzed before and it isn't stored in the database, our API will then get the raw patient data from Azure Blob Storage. Our client uploads the raw patient feedback to Azure Blob Storage every month. The comments from the patient feedback retrieved from Azure are then sent to either the Text Analysis API or our own machine learning model, depending on what version of our project you use. The sentiment scores generated for the comments are then stored in the database along with the rest of the analyzed data, so if requested again in the future, there is no need for repeated analysis of the data. In the rest of this demo, I'll do the following. I'll provide an in-depth walkthrough of all of our Power BI visualizations, a demonstration of the 3 endpoints provided by our API, a demo of the version of our API hosted on Azure as a web app, a demo of the system's refresh feature, including upload and analysis of a new month's worth of data, a demo of the version of our project that makes use of our own machine learning model for sentiment analysis rather than a text analytics API, and finally I'll go through our achievements list to ensure all features marked finish have been demonstrated. So this is our Power BI file. It's currently empty because no data has been loaded into it. In order to load data into it, we need to run our API. The version of the API I'm going to use for this part of the demo is the version that uses the text analytics API for sentiment analysis, and it also makes use of the real patient data our client gave us. Because it makes use of the real patient data, we haven't hosted this version on Azure, so we need to run this on our local host, which I'll show you how to do now. So you're going to want to activate your virtual environment. Then you'll need to install all the requirements, which you can do via the requirements.txt file. You then want to run the unit test. You then need to do set flask app equals application.py, and then you do flask run. And as you can see, it's now running on localhost. Next thing to do is go to the deployment manual. You can then copy paste this code from our deployment manual, that, return to Power BI, then on the table called feedback, right click, click on edit query. This dialog box pops up, double click on source, select all and replace, click OK, click the red X, then select to apply changes now. If we look at the API, you can see requests are being made to that API. So the endpoint I'm using here is the one that collects the most recent 12 months or the most recent year's worth of data. It's about 20,000 records it's collecting. So as you can see now, it should, 20,000 rows loaded. And as you can see, all the visualizations are now in place. So this is our home page. It shows a high-level overview of how the hospital is performing as a whole. So down the left, we have a set of key performance indicators, such as best performing clinic, best performing months. We also have a donut chart to represent the positivity. So you can see this is showing that 99% of all the responses received in the past 12 months are positive, 1% being negative. We have a pie chart to break down the response types. So this is telling us 88% were extremely likely to recommend the NHS to someone, 10% were likely to recommend, and we have 0.5 each here for unlikely and extremely unlikely. The main feature of this page is the time sentiment graph overlaid with the quantity of responses. So the purple bars represent the quantity of responses received for that month, and the line graph going across is the average sentiment score for that month. Another nice feature of this page is that we can filter all of the visualizations on month just by selecting one of these months. If I select these months, all of these scores have changed. This has changed. You can see for April, 99.4% positive. If we wanted to analyze, say, the first quarter of 2019, we could select January, February, and March. And then all the visualizations have changed to only reflect the selected data. Up the top, we also have an indicator for the most recent months of data. So currently it's showing March because that's what we've selected. If we go back to all the data, because it's changed to November, so the most recent month for which we have data for is November. And it also shows you the last refresh date. So the last time this was refreshed was the 1st of March. This is the recent news page. It provides information based on the most recent 3 months worth of data. So on the left, we have a visualization to show you the top 5 best performing clinics for the most recent 3 months. Here we have the breakdown in their sentiment scores. If we go below that, you can see all the comments received from those clinics. You can filter these comments based on a selected clinic. So if I select full service, all the comments now are from that clinic. Similarly, the middle visualization is for the bottom 5 worst performing clinics of the most recent 3 months. We have their sentiment scores along here. And if I were to select one of them, such as B6, all the comments filter to just be from B6. The far right side shows you all of the complaints received from the most recent month, and below that we have clinics for which no feedback was received this month. So this means that we have feedback for these clinics for other months worth of data, but for the most recent months we don't have any feedback for these clinics, which may be something to take into account for other visualizations we use. We also similarly have the most recent months for which we have data available for, and the last refresh date up at the top here. This is our advanced filter page. It does 2 things. The first is that it allows you to analyze the performance of a specific clinic over time using the monthly average sentiment score as a performance indicator. The second is it allows you to compare the performance of multiple clinics against each other using monthly average sentiment score as the main comparator. Here, we are using it to analyze the performance of a clinic called A1 over the past 12 months. The bars indicate the average sentiment score for that month, and if we hover over them, a tooltip comes up showing you the exact average sentiment score. The black line indicates the total number of responses that the average was calculated from. So for May, the average sentiment score was 0.7728, and that sentiment score was calculated using 40 responses. We can also use this page to compare the performance of multiple clinics against each other. To do this, we use the clinic filter and we select multiple clinics. So I'm going to select A1, A2, and A3. As you can see, the visualizations have now changed to include all 3 clinics. The bars still represent the monthly average sentiment score, and the black line represents the total amount of data used for that month. So the total of these monthly average sentiment scores are based off of 66 responses. Down the side, we have some key statistics such as the best performing month and the best performing clinic. These are provided so that you don't have to search through the visualization to find commonly asked questions such as which clinic is doing the best and which month is doing the best. You can also filter this visualization by the period. So say we only wanted data for the first 3 months, we can select January, February, and March. Those are the first 3 months of 2019. We can select as many as we want. We can also filter by positivity. So if you only want to analyze the positive data, we can select that. Or if we only want to analyze the negative data, you can select that, of which there isn't that much. We can also filter this page by response type. So we can analyze only the responses where they were extremely likely to recommend NHS, or a combination of extremely likely and extremely unlikely. This is the responses page, and it mainly deals with the comments provided by the patients. So on the top right, we have a visualization to show the comments that received the most positive response types. And similarly, on the bottom, we have a visualization to see the clinics that received the most negative response types. If you wanted to expand these visualizations, or any of the visualization, in fact, you can click on focus mode. That will open up in a full page view. This can also be done with filters, such as this. You can select focus mode here, and you can more easily select data if it's a large list. We also have a word cloud in the center here. This word cloud is based off the frequency with which words occur in the comments provided by patients. If you hover over the word, it will show you the number of times with which that word occurred in the comments. Another nice feature is that if we select a word, such as staff, all the comments here and all the visualizations will actually filter to show you the proportion of comments from this clinic in which the selected word occurred, and also all these comments now only include the word staff in them. The reason this is useful is because if you want to identify issues in a hospital, you can filter positivity to only include the negative comments. And then we can select a word here, such as doctors, and we can now find out what issues people are having with doctors. So this is just a nice way of identifying what issues do people have, why they're being caused, and also you can see in what departments are people having issues with doctors the most. So you can see this is suggesting that the acute surgical unit probably have the most issues with doctors. Similar to the advanced filter page, we have filters for time, clinic, response type, and positivity, all of which work well. Another nice feature of our Power BI file is that the only table generated from our API is the table called feedback. All the other tables are generated using SQL that we've written. So if I were to select all months, you can see we've written a set of SQL that creates the table. We also have functions within these tables that calculate certain column headings or visualization entries. This data is generated once the table called feedback is populated. Once this table is populated, all of the SQL runs, all the other tables are made, and then all the data from those tables are used to populate the visualizations. So I'll now demonstrate the endpoints we have in our API. The endpoint used to retrieve all of this data was one that gets the most recent year's worth of data. If less than 12 months worth of data was available, say only 6 months of data was available, if we requested for the most recent year's worth of data, it would return that 6 months worth of data. I'll now demonstrate an endpoint that retrieves a specific month's worth of data. So for this endpoint, you need to pass in the month and year you want to retrieve data for as URL parameters. So I'm selecting data for month equals 4, which is April, and year equals 2019. So I select OK. Let's apply my changes. So now our API should return us only a single month's worth of data for April. Yep, and you can see we only got one month's worth of data. The most recent month for which data is available is April, so that worked fine. We have one final endpoint which retrieves the X number of months worth of data, where X is a number to be chosen by the user. So if I wanted 3 years worth of data, I would put in 36. So that endpoint is called most recent months. And here, so as I said, if we wanted 3 years worth of data, we would type in 36 here. I'm going to instead select to get 7 months worth of data. So this should now return us the 7 most recent months worth of data. And we just have to wait for the API to check the database for the data, then return the data from the database back to us. As you can see, there are now 7 months worth of data in the Power BI file. This also returns the 7 most recent months worth of data. So November 2019 is the most recent month for which data we have available in our Azure Blob storage. So that's the data retrieved, and then it worked backwards from there. I'll now demonstrate a version of our API we've hosted on Azure as a web app. This version of our API makes use of mock data we generated ourselves rather than the real patient data given to us by our client. This is simply due to security reasons, as we did not want the real patient data our client gave us to be publicly available. To do this, I'm going to go to the deployment manual. I'm then going to copy the code here, which now makes a request from the hosted API rather than the one from localhost. I will then right-click on feedback, edit query, double-click on source, and we'll replace this. As you can see now, the host is patient service analysis tool.azurewebsites.net, so we're no longer using localhost. If you copy-paste from the PDF version of the deployment manual, you will need to add a hyphen between analysis and tool. For some reason, copy-pasting from the PDF version tends to remove that hyphen. So now we will click on OK, and we will apply these changes. This is now making a request to an API hosted on Azure. From there, we'll then retrieve the data. And yeah, this is our mock data. The rest of the Power BI file is the exact same as the other API demonstrated. So I'll now demonstrate how to upload and refresh data. So to do this, we can go to our Azure Blob Storage resource and then click on Upload. We'll then select 2 folders. And these are 2 folders I've generated for this purpose. So this is data for March 2020. So there are 2 Excel files being uploaded, both containing data for March, one positive, one negative. So we've now uploaded that data to our Azure Blob storage. The data looks something similar to this. So there's 1 column for clinic, 1 column for response, and 1 column for comments. If we now go back to our Power BI page, if we press refresh, what should happen now is our API checks to see if the data for March is stored in the database. Because it's not, it would then go to Azure Blob storage, get the data, send the comments to the text analysis API for sentiment analysis, write into the database, and then it will send all of that data back to Power BI to be visualized. As you can see, before we had 7 months worth of data, we now have 8 months worth of data, and the most recent month data has changed to be March 2020. Similarly, the date has now refreshed to be 22nd of March, which is the date and time I'm recording this demo. I will now demonstrate a version of our API that makes use of our own machine learning model for sentiment analysis, rather than a text analytics API. This version of our API hasn't been hosted on Azure, so we'll need to run it on localhost. This version of our API also uses the mock data we generated ourselves, rather than the real patient data, simply because there's less of it, so it's quicker to analyze. To do this, we first need to run the version of our API on localhost that makes use of our own machine learning model. And as you can see, it's now running on localhost. The next thing to do is go back to our deployment manual, copy paste the code for making a request to localhost, then edit the query, public open source, paste that in, and as you can see, it's now making a request to localhost, and the endpoint is past years worth of data. I'll click OK and select yes. Now, the API that uses our machine learning model accesses the same database as the version of the API hosted on Azure, meaning the data here hasn't actually changed. However, all of the data here has been analyzed using the text analytics API. So what I'm going to do now is go on MySQL Workbench and delete data for the most recent 4 months. So I'm going to run that. I'll now hit refresh in Power BI. What this will now do is it will make requests to the API running on localhost. This API for these first 4 months will check to see if it's in the database. However, the data for here isn't going to be stored in the database, so it's going to analyze the data again, but this time using our own machine learning model. As you can see, that provided different results than the text analytics API. I will now go through and check I have demonstrated all the achievements we have marked as finished. Number 1 says that the system must be able to be used by any hospital that collects feedback using a general FFT schema. For this, we have hosted a version of our system on the Aperta Foundation's GitHub and made it open source so that it is now part of the official NHS Index of projects. Our repository provides not only the code, but sample data collection forms, mock data to test the system with, a sample Power BI file with visualizations, and a more detailed user and deployment manuals. These manuals include instructions on things such as how to create an Azure account so the system can be set up from scratch. In this repo, we set out a schema for collecting data that is the same as the FFT format. That means any healthcare service using FFT forms for feedback collection can make use of our project. Number 3 was shown to be achieved when we demoed the donut chart on the homepage, showing percentage positivity for the hospital. 4 and 5 were both shown to be implemented during our demo of the homepage. Number 6 says that the homepage should have an overall view of all departments for the whole organization. The visualizations on our homepage take into account all data received from the entire hospital, meaning all the visualizations and statistics shown here give an overview of how the entire hospital is performing. Number 7 and 8 were shown to be achieved during our demo of the advanced filter page. Achievements 9, 10, and 16 regarding the filters have been demonstrated on the advanced filter and responses page. Number 11 has been demonstrated as we've shown our visualizations are filtered in real time. They're located on the same page the visualizations they're filtering, and their placement does not interfere with other visualizations. Number 12 is a bit subjective, but we feel we've spaced out our visualizations enough, and when we demoed our final system to our client, she also felt the same way. 13 has been achieved as we're using Power BI as our front end. Power BI is the built-in feature to export reports as PDFs, where they can then be printed off and stuck on bulletin boards. 14 was shown to be achieved when we demoed the responses page. 15 was shown to be achieved during the advanced filter page demo, where a black line shows the volume of responses received. 17 was not implemented. 18 has been achieved as we're using the NHS blue and white colour scheme and have included their logo in our Power BI reports.